Do you struggle to comprehend difficult ideas as a mechanical engineering student? Do you wish to sharpen your problem-solving abilities and achieve academic success? You can excel in your academic endeavors by taking advantage of our tutorials, which cover a wide range of subjects. Take your knowledge of mechanical engineering to the next level by joining the thousands of subscribers who have already benefited from our tutorials. So our problem for today: a horizontal steam engine is running at 150 revolutions per minute, has a bore of 200 millimeters and a stroke of 400 millimeters. The connecting rod is 1 meter long and the reciprocating parts have a mass of 60 kgs. When the crank has turned through an angle of 30 degrees from the inner dead center, steam pressure on the cover side is 0.6 Newton per millimeter squared, while on the crank side is 0.1 Newton per millimeter squared. Neglecting the area of the piston rod, determine A, turning moment on the crankshaft, and B, acceleration of the flywheel if the mean resistance torque is 600 Newton meter and the moment of inertia is 2.8 kilogram per meter squared. So for our solution, we're given the engine is rotating at 150 revolutions per minute, N, which is the ratio of the connecting rod to the crank, is 5. The bore D is 200 millimeters. The stroke L is 400 millimeters. Mass of reciprocating parts is 60 kilograms. Length of the connecting rod is 1 meter. Theta is the angle between the inner dead center and the crank. P1 is pressure on the cover side. P2 is pressure on the crank side. So first thing we do is we calculate the area of the piston, and that is given by, we get 10,000 by millimeter squared. Piston load is given by equation 1, from which you can be able to get the piston load, and it comes to 15,707.96 newtons. Inertia force is given by equation 2, and if you plug in the values, we get 2860.287 newton. Equation 1, Fp is equals to 15,707.96 less 2860.287, and that gives us a value of 12,847.667. Next thing we do is we need to calculate phi, which is the angle of inclination, and we get it from the relationship between phi and theta, and our angle of inclination comes to 5.739 degrees. Now we are able to calculate the turning moment of the crankshaft, which is given by equation 3. After plugging in the values, we get the value of the turning moment as 1,508.417 Newton meter, and that is our answer. In order to calculate the acceleration, we know that the accelerating torque is equal to the turning moment less the mean resisting torque, and that will get us equation 4. From the values you have, turning moment is 1508.417 and mean resisting torque is given as 600. Giving us an accelerating torque of 908.417 Newton meter. We know the relationship between accelerating torque and moment of inertia and acceleration of the flywheel. From there, we can comfortably calculate the acceleration, which comes to 324.4 radians per second square, and that is the answer we're looking for. Thanks for watching. Like, subscribe, and share.